So I'm going to present you the same story at the University of Zurich, since we are now in Zurich, and also Bernd has started a bit over a year ago, and I just started with this unit in January. So it might be interesting for you to see how we are doing things, and I will also go through a little bit what we do with this Service and Support for Science IT unit. So Service and Support for Science IT, S3IT. Yes, I mean, I probably shouldn't say this, but I wanted to just call it Science IT, but they didn't allow me to do that. So maybe we can go back to that, because S3IT is obviously a bit complicated. So I'm going to talk about, of course, what it is, and also how we do triage between the different sorts of applications to support, HPC being an important part, what the business model aspects are, and then also, if there is time, to go into a little bit how we do the science on the cloud, what the challenges are, and what the opportunities might be in the future. So the challenge also for us, this is a very old slide actually that I've been using already for SystemsX in the Scibit project, is the capability to scale and to enable science. So mostly, just as Bernd said, I mean, you want to provide people capabilities to do more and better things. And focusing on the people who are not that savvy, they just want to use the stuff and forget about it. So of course, in this community, the HPC, where we are really interested in how things work, that's not what it is. But in a lot of projects that we are supporting, that's exactly what they expect us to do, this little miracle in the middle. And then they can just continue working and publish their Nobel Prize papers. So this is, of course, the task that we close this gap. And I also have not such a nice drawing as Bernd had, but maybe basically the same. So we have this kind of things in research support, in this case biology. And what we then try to do in this gap is all this automation, development of things, hand-holding, and doing basically things that people could do in the past in collaboration with computer scientists. But now, of course, computer science also has moved on, because you cannot publish the same paper over and over again. So we basically provide this kind of support as a professional service. So on the left hand, we have the local IT resources, which I'm covering now. So maybe I should move over a bit. And then we have the research labs and the core facilities, and this is where we see ourselves in the middle. So we also try to work with local IT people if they are available. Quite a lot of labs have a local IT person, and we don't want to replace them at all. Quite the contrary, we want to make sure that they can do more for their local researchers. So the name of the game on the marketing slide is that we provide a faster time to solution, access to infrastructure that is scalable, flexible, and removes barriers to research. Sometimes people think that they cannot do things because they're limited by their infrastructure, so this should be removed. And that's the enablement part. All right, so what's the mission? Yes, so the mission is basically to support science, to be a partner to research units in their science, and provide services through the partnerships. And this includes consultancy, software development, access to competitive infrastructure, library of tools, and of course project management and training and education. And also we want to collaborate nationally, internationally with our partners and other science IT units, and of course maintain a high level of local expertise and know-how, and provide feedback to the governance of the University of Zurich so that they can continue to plan their things also with our input. Currently, the layout is just like this, but this doesn't have much to say. I will tell you in a minute. It's just a logical layout. So we have infrastructure, projects, and collaborations that we deal with. And the reason we don't do this hierarchically, because we try to map ourselves the way research works, which is a federated model. It's not really hierarchical. And so you have these small, large groups of people that you want to work with. And so actually what we do is that we have a core team, and we want to build side teams and have embedded people that have very specific organizatorial tasks. So in the core team, we of course do the central infrastructure provisioning, consultancy, all services that we don't need to be acquiring additional funding for. And the side teams are then now the existing IT people already in the groups that we try to enable and strengthen and make sure that they cooperate and do more. I have an example for this. And the embedded experts, or embedded people, are then those who are working on projects, who are funded by projects, and that we, of course, involve in the whole science IT community, but they are really very strongly involved in those individual projects, most often working inside the research groups directly, but not doing so alone anymore, but rather as part of a team. The current staffing is this, so we have like 5-6 staff in the core team, which is relatively small, and we are, of course, trying to do our best to deal with all the work we have. Then there's one side team so far. This is a team of 6 people, out of which we only fund half a person, but they already existed. So this is actually at the Department of Anatomy, Biochemistry, and the Central Microscopy facility. So this is one, it's very funny because one unit is from the science faculty, one is from the medical faculty, and the other one is a central facility. So they are as heterogeneous as it gets. They happen to live in the same building. This is why it was easy to motivate them to kind of merge their science IT support efforts. So this team still provides, of course, the support to these 3 units, but they now also can do more because now they have the capability, having optimized their team, to also provide services to the university at large, to other departments like virology or psychiatry who don't have such severe IT needs and can be covered by these people. And finally, in projects, we have already quite a few of projects funded that we need to also get the people for. And both the teams we would like to replicate and the projects, of course, we would like to get more. So this is where we can grow in terms of size of our facility. So how the interactions? So again, we provide services to projects, research groups, and faculties. So these are the internal users. And I use these colors because they are, of course, super heterogeneous, but I'm not telling you anything new. And on the left-hand side, we, of course, have agreements with central IT and the core facilities inside the university. And, of course, our vendors, CSCS, Switch, all the other people that we tightly cooperate with. And then we try to, of course, map these services. So our core business is really project support. And I already told you all this. So this is, simulations, data analysis, integration, application usage, and we'll talk more about that. But actually what we always try to do first whenever somebody contacts us is to talk to them directly. So, all right, so you just wrote us an email that you want access to our cluster or our supercomputer. Why don't we just sit down and talk about that first before just giving you an account? So we would like to understand really what the science is that people are doing. We have the ambition to have this capability in the team that we can get a rudimentary understanding of their science so that we can also advise them whether they do the right thing or whether they might have some inhibitions because of historical reasons. They thought this is the way to do things, and actually we know that with modern technology they might be able to do more. One example is that sometimes students come with the idea that, I want to run MapReduce, and then you find out that actually for the research project they don't need MapReduce at all. The database is more than sufficient, but they just would like to have some fun trying MapReduce, which is fine, but then it's a different context, of course. Okay, so in terms of infrastructure, we have the supercomputing part. So this is currently the Schrödinger cluster at the university, and in terms of service that we provide, this should be looked at as a scientific instrument for people. So this is really, we have groups, as of course most people in this HPC community do, that without a supercomputer you basically can't work, period, because you don't have the capability to run your simulations. And in the university, these are in computational chemistry, mathematics, physics, quantum chemistry, and usage is pretty much continuous. And then we have a large category cluster computing that also was mapped to the Schrödinger cluster to date, but which I would like to separate and have a dedicated infrastructure for that, so that it's a better separation between the savvy and the not so savvy people. So this is just a workhorse. So this is where people say, I don't care what it is, just get it running. And of course, quite often you have people who are then more savvy, students who want to know more, and then of course we can lower our involvement and say, okay, you can do it on your own, or those who don't even want to see that there is a cloud, and this is what Sergio is also going to talk about in a minute. And this is, not continuous. So this kind of usage comes in bursts. They have a project, they run it, and then it's done, and then maybe next project is just 3 months later. And finally, we have server computing, which is also used for science, where you have maybe powerful desktops or graphical workstations, mostly for visualization, for maybe just interactive usage of things for which you do not need a cluster, but it's still important to you. And we also want to support this kind of computing. All right, in terms of storage, we have also identified very, very crudely a few classes, and this most certainly will evolve in time. So we have this request for large, dirt cheap storage. And the use case is that people produce sometimes even petabytes of data that is probably easy to regenerate. So if you lose it, it's not such a big deal. They could regenerate it, remeasure it, whatever, but it would be painful. So it should be available, but shouldn't cost anything. I need secondary copies. I don't want to lose stuff. But I don't change it much. I just add to it, right? So this is just generating new data. This is the very, very common use case. And then there's the working storage. This is where I actually do my analysis, my simulations, where I then read in the data from the project store. This is much smaller. This kind of data also may live in files, but mostly in databases. And lots of server-side processing is being done here. So on the cluster or in the cloud, you see processing on the large number of data points, if you have that, and then you produce secondary data, which you then store in a database very often. And this is a rare use case that is currently only locally being done at the Institute of Informatics at the university, where they are experimenting with data streams, like the Twitter streams or sensor network streams or some such, where they really focus on I/O. That's also a few hundred terabytes, so it's a lot of data, it's fast changing, and you want to do immediate analysis. And this use case we currently don't support as a service, but we of course cooperate with the Institute for Informatics and see how this evolves in the future. All right, coming back to supercomputing. So this is our Schrödinger supercomputer now, which is basically beyond end of life already. And it's a Sun constellation cluster with 4,500 cores, quite a lot of power consumption these days, but this is why it's end of life. And there's nothing wrong with the computer at all, except for the support given by Oracle. But it works. We just have replaced the storage system, and it will certainly operate until the end of this year. But starting 2015, we have already agreed, and the university board has already signed off on this. And I believe also the ETH board has signed off of not the board, but the ETH governance, that the University of Zurich and the ETH are cooperating with CSCS, and that there will be the next generation supercomputer of the University of Zurich will be simply a co-owned machine hosted at CSCS. So basically CSCS we just have a share on one of the machines that are being now deployed at CSCS, from which I'm sure we will hear more in the next HPC event. And we are just drawing up the responsibilities and agreements. So we will have very moderate infrastructure needs for supercomputing starting 2015. We certainly need the good wide area network, and we need some local data caching. But other than that, supercomputing infrastructure is taken care of. the support is still done locally. So we will support the local teams for the usage of this machine as well. And we, of course, work tightly with CSCS on all the support aspects that need local involvement. But also this we are establishing exactly this kind of responsibility sharing interactively. Right. So the CSCS share, this may change. This is what I had in my things. So this is like 288 nodes, 6,900 cores, 18 terabytes of RAM, something like that. All right. So capacity. This is where we go to the Science Cloud, and this is what we have. Not like Brutus, we have not put it in the same system. We are separating it out. It's really a fully cloud cluster, so you don't have any more nodes that are metal. If you want to do cluster computing with us, well, we can help you buy your own cluster if you get approved, or we can provide you with a virtual cluster. And we have a pilot cluster built up. It's called HOPS. Sergio will talk about that in great detail. That has around 800 cores today. It's very heterogeneous boxes. We just are testing the scalable storage part. We want to extend this facility by 2015 to around 4,000 or 5,000 cores. And for this, we have some money to buy new systems. And the idea is also that we simply do not switch off all of Schrödinger, but we just switch off half of it and keep the other half for spare parts, right? So we also can do that because we are not currently paying for the electricity bill. That's, of course, a temporary measure until we get another batch of funding to replace the second part as well. But we wouldn't be able to go to 5,000 cores if we didn't do that. And we do have, however, also some funding to spend this year on new scalable storage that is then specifically for the purpose of research storage and has a bit less of quality requirements than what currently people receive from the IT department. All right, in terms of servers, this also can run on the cloud, but of course these are more, so they are a bit different, and this is where this analogy comes in between pets and cattle that you might have heard already, that has been coined actually by Randy Bias from Cloud Scaling a while ago, and CERN has made it more known. This is a slide by Gavin McCance, where he just says, okay, so the pets, these are the servers basically, that you really would be very, very annoyed if they would be lost or destroyed. So if they are ill, you nurse them back to health and so on. And you also work on them manually, so you spend time with your pets. And then you have the cattle, which is then the capacity. So lots of the same or very similar. Some is brown, some is bigger, some is smaller. But basically, if you lose one of those, you just get another one. And you don't even need to see your cattle. You just have your herd, and you have your helicopters cruising around it, right? So this is this analogy which describes pretty well these two aspects of capacity and the servers. But you can still cover both on the same infrastructure. You just have to treat them differently. All right, and finally, what we also do at the university now strategically is that we try to consolidate all of these data centers into one or two. Don't ask me about the central one, because this big red dot is the central data center, which also is beyond end of life, but the university is still deciding what to do about that. There will be something latest in 2021, because 2021 is when it will be destroyed as in its current form and will be completely renovated. This is the latest news that I have from the building people. So we have still 6 years of time, which means now the university has decided where to put the central one. But there are lots of non-central ones, so locally at the ETH campus and also outside in Oerlikon and many other locations, where people have just put some mini cluster under the desk, or there are little rooms with some cooling and air conditioning. And of course, it's not very efficient, and you cannot scale in those rooms. So there's a consolidation effort. We have already talked to all these people, and the idea is that we really move it here, and that those little rooms, one by one, can be repurposed to lab space that they really need. So they are really very much on board with that idea. All right, one final word on security, because you cannot talk about clouds without talking about the S word. So in our simple-minded experience so far, we have basically 3 stages that we look at in the science world. You have the preparation stage and the proposal stage, and at this stage you really want to work in a private environment, so you don't want to share much with the world what your latest idea for the next grant is, because that's competitive. And then you got the grant, mostly with a consortium these days, where you want to share stuff, but it's still not public, because you don't want to be scooped by your competitor, but you want to open up because you want to share, at least within your consortium. And then finally publish it and everybody is happy, and you actually want to open it up as wide as possible, because then you get more recognition. So in terms of security, you have to cover all these aspects: private, shared, controlled, and completely public. And you have to simply build your evolution with this in mind. There are some exceptions, of course, but I wouldn't build my cloud system based on the exceptions. So medical data has lots of regulations on patient data, of course. Law and business, they have also confidentiality constraints in their projects where they have to keep certain things local. And also engineering pharmacology, where there might be some money to be made with patents. Also, these guys are really picky about storing their results on Dropbox, for example. So you have to also accommodate these, but again, the large cluster environment, you shouldn't map after these guys, because except for medicine, they will not mostly, they will have their own infrastructure already. So the medical domain is building their own, but they have an amazing amount of money, so they will do that. And these guys already have their own infrastructure, so we can just simply copy what we do or enable their own, and then they are safe, if necessary. And after certain stages of the projects, also everything is public again, and then they can come back into the global infrastructure. For the cloud implementation, Sergio will talk several times about what we do. So we have an OpenStack-based cloud using Ansible as the configurator, a Vagrant-like system called Elastic Cluster for deployment of the virtual clusters. And then there's GC3 Pi, which is a Python framework to actually run things as applications without you even noticing that in the background you have virtual machines going up and down. And database management is with, we also use the OpenBIS framework that Bent has just mentioned, and all the other applications he also mentioned. So we do not want to build our own as much as possible, but really reuse everything that we can. And the cooperation between ETH and university is just historically very strong. We have been sort of raised by the same family. Business model is also an important aspect here. So for the supercomputing part, we know we have every 4 or 5 years we need to invest. So and we want to put also the research groups into commitments, so that they know that they will have to ask and motivate, work on getting grant money in addition to what the university is paying to really get this money to finance their scientific instrument. And this has been worked in the past. We are supporting Thomas Schultes' aim to get money from the central government as much as we can, because we are profiting from that also very much. And that's the plan for supercomputing. For commodity, this is a bit different. So here, the 3 main points that we need to have is flexibility, and of course there's flexibility. Because you want to go up and down and provide just the fee to your users, you want to avoid that there is again some grad student who feels that buying his own little cluster under the desk is sexier than using the central one. So it has to be so easy and cheap to the professor that it doesn't make sense to do that anymore. So it's a fee. It's not full cost. We cannot do full cost. We have to, be better than full cost, much better. But still, inside that fee, you can have a subscription model for a yearly, monthly subscription, or also just the pay-per-use model. And for that, you need, of course, the proper monitoring tools in your cloud. And for the servers, that's also the same. You have a yearly or a monthly fee, and of course, here size matters. And you have the same concepts as Amazon has, just pay for the size that you use. But for all of this now, if you categorize it this way, at least for the cloud and for the storage, you have a yearly acquisition that you can always plan. You always know you will spend that much this year, that much next year. You buy a new batch, you throw away the old one, and then you just grow your system. And for the cloud, it's not too bad if it's then a bit heterogeneous. Of course, you want to avoid it as much as possible for obvious management reasons. But being a public institution, you have to always put out a procurement call. You will end up with a heterogeneous system. All right. For the FTEs, the business model is also this, that we have a core team. This is paid by the university, and the university, of course, notoriously lacks money, so this is a small team. And then we have these side teams. These are mostly paid for by the local institutes. And then we have the project teams, and those are where we can really grow with the third-party funding. And what we try to motivate our research groups is that they put us down as co-PIs in their projects, or they put us down as consumables in the project, so that we get the funding and the volume of the funding so that we can actually support them. And this comes with their own governance, because at the end of the day, if you do a good job, they will come with more projects. If you do a bad job, they will just not come with more projects anymore. So we have to really be good at it. In current projects and partnerships, we have everything's pretty much the same that Bernd has also listed. And especially also cooperation with other science IT units, and CSCS and Switch as central infrastructure providers. So what is our experience so far? Well, supercomputing users are a minority, although in terms of course, CPU time, they are by far the majority. But in terms of people, I mean, this is just a few groups in that sense. And they need excellent support, so we need to work with them very, very tightly. But the hardware can be completely outsourced in our case. And of course, you have to have a trust relationship with this outsourcing, but we believe we have that with CSCS, and that this will work really nicely. For the cloud, you also have pretty good experience so far, and we can safely say that for a vast majority of scientific use cases outside of supercomputing, this just works well. It's really nice. I cannot complain about enough work right now. So even though we did not advertise ourselves, we just exist since January at the university much. We get phone calls basically on a daily, weekly basis where people want to get advice, help, involve us in a project or anything. So it's the concept is working, and also we have shown, and Sergio will talk about that, you know, that we can meet the needs of these projects, and those we cannot meet, we probably can help them to build their own. And you know, I think today we can also state that in 2014, at least, this is the case, that we have to use local infrastructure for data, network reasons, and memory-intensive workloads. I mean, some of that, of course, we could also use the CSCS machine for, and there is a threshold where we will do that. But also CSCS will not approve projects also if you apply for just time there, if they don't match the things that CSCS has been built for. And for these things, we have to have local machines. Having that, of course, at the end of the day, it should be hybrid, because we want to fill our local cloud, of course, with completely to have it fully used. And in time, we will see how much do we really need to buy ourselves, and how much can we burst out for workloads where data security is not an issue and which is not too data intensive. For example, to switch to ETH, we just have actually used Switch for a few virtual machines at times of maintenance. And that works really nicely. So this also we have to set up, and I hope we get funding from CRUS to actually do that. But that's certainly the plan. All right, and the evolution. So we'll have supercomputing and CSCS, commodity cloud and storage locally. And in 5 or 10 years from now, it could be that we can, house it out. I mean, it's not impossible that prices will be such that it's completely economical to not run your own data center anymore, but just put your gear into someone else's data center. Because just in Zurich, there are so many data centers around now who plan for 5,000 racks or some such that this probably will be cheaper than if the university builds its own, but maybe they will build its own anyway. Or just rent. I mean, if the cloud costs are coming down a lot, then it will be interesting to rent clouds so that we just buy just as we could today from Amazon, which is not yet very economical if you really use it all the time. For burst cycles, it is already very, very interesting. But maybe in the future, it will be also interesting for just usage. We don't know. So we want to be flexible on that. And the factors, again, are, of course, cost and security and data. We'll see how it goes. But we want to be prepared. And we feel if we have a local cloud that we can burst and then move out or in, that we can be prepared for this. All right. So just to sum up, our approach with the research groups is to really hook up with them physically. We sit together in the same room and we talk to them as much as we can. We try to see this as a partnership and not just as a service, that we write proposals together and we are involved in the projects really tightly. That's also the only way we can scale in terms of manpower. And we provide them, of course, advice and best practices as much as we can, as much as they need it, right? Because everybody is different. And also the other strategy is that we have very strong partnerships, so we don't want to work alone. We want to work with the community, and most of you are here. So with our local IT department, with CSS and Switch as providers, but also other science IT units, and communities like Systems X, CHIP, the Swiss Institute of Bioinformatics. And the libraries are also a very, very interesting partner, and we have already started to work with them, at least locally, because at the end of the day, data also should be published and reused, and the libraries have realized that this will be their job, but they already came to us for help to be able to plan it in terms of infrastructure and, of course, availability. So they are also a very interesting partner because every scientific work can start with a research in your available data that you already would have in the library. You can even do full science just by mining available data. And this will be more and more the case. So currently it's not yet the case in every domain, but we see this happening more and more, and that's why the libraries are a very important partner to us. And of course, also finally, it's also important that we can claim that what we do is really useful, it's really well appreciated, and that we take this information back to the funding agencies and say, well, if you see IT consumables or informatics or science IT consumables or partnership of a science IT unit who happens not to be a professor in a proposal, don't just strike them out, because this is really necessary to be funded as part of the research project. We are not there yet, so sometimes people are being struck out here. So it's relatively dependent of what kind of reviewers you get, and also the what kind of science you work in. And of course, we would like to be even in the position where the Science Foundation or other funding bodies even come back to us, and this is also true for HPCCH, I'm sure, that if there's a project they want to approve, that there is maybe a second round that checks the technology, whether it's actually realistic in terms of capabilities of the infrastructure or the applications, or what they claim that needs to be done in terms of software engineering is actually realistic. At least in biology, we have seen that quite often projects get funded where we then realize that the work to do the data integration and data handling and data management has been vastly underestimated. All right, so that's it. And I stop here because I've used up 35 minutes already of my 30 minutes. And if you have questions, please ask, or we can continue discussing over lunch later. Roberto.
Well, renting space outside would mean that you will have to pay for the electricity.
Yes.
And this might be a big problem. Because for the moment, most IT departments don't pay for the electricity they consume.
So obviously, the discussion at the University of Zurich is such now that we are now discussing this with the department that does pay for the electricity. So these are the infrastructure people. And their considerations are different. They say, okay, so now we have a deal with the electricity company of the canton of Zurich. And actually, the air of the data center that is heated up in winter is being used to heat the local building. So if I go out, I pay the same electric bill. I can even have a deal with the canton of Zurich that the price I pay there is the same price as here, but I cannot heat my building with it anymore, right? So these are, I mean, they're thinking on these scales right now. So for them, the economy of scale must be really interesting, or they need to save on additional people, maintenance, whatever, that of course they would do if they build their own. But these total cost factors are looked at, yes. So it's not me who decides. This is the university building department. I mean, these guys have millions of Swiss francs to make whole buildings. I mean, these guys decide that. Yeah. Yes?
So part of the problem is if the budget for energy is kind of in the, or the money for energy is kind of in the wrong budget, so you don't see it.
Yeah.
That can even lead to decisions that are, when you look at the overall economy, not efficient. But I guess that is changing now. I mean,
so
the universities also try to make this transparent, that you know how much money you are spending also on energy, because the energy costs, they are no longer negligible. Like they used to be,
yes.
or people at least believed it, but it was also a smaller fraction, and they are no longer negligible. And for example, for Euler, we are now seeing energy costs, right? That's the first.
Yeah. So also the outsourcing to CSCS was such that now I have had to receive additional budget from the university to be able to pay the electricity bill, which is actually, I would like this to be paid by the infrastructure people. But the mechanisms of funding at the university are like this. So yes, this is a problem. But they realize that they need to calculate total cost. So this is moving. It's moving very slowly. But I don't want to be blamed if the university builds a data center, which is then completely underutilized and costs them a lot of money. You see what I mean? Because it might be that it's underutilized because we realize that actually it's much more economical to go further to CSCS, to go to some other data center or some such, and then they have built it and it's not used. So all I'm telling them that don't look at me for stuff. What I need is flexibility. And if for you there are other factors like heating or stuff like this, then okay, all I need is like, give me 2 times 1 megawatt for now or something like that we can be safe, with 2 sites or something, because there are certainly use cases where you need that. This is also what the IT department needs. But don't use my use case as an argument why you build your own. So I make them think on their own, which is really new for them. They also like to be told what to do.
Because you can tell them they can swim in the lake of Lugano.
Of course. And it's already warm. Yeah, the Lake of Zurich is a bit further down, but I'm sure you could do the same, right? I mean, you just cool it to the lake. You cannot?
No, the temperature is too high. I mean, the temperature loss, since the Lake of Zurich is not so, it doesn't have this low temperature, so the temperature loss would be too high.
So you would need to build a new data center by the lake, But anyway, so this is the discussions that you kick out a few millionaires from the Gold Coast and then build a data center. Yeah. All right, so we can continue this over lunch, I guess, and maybe move on to the next.